Artificial intelligence is advancing faster than the hardware beneath it can sustain. Every year, models grow larger, workloads get heavier, and demand skyrockets. But the chips powering AI cannot scale forever. At the current trajectory, AI will soon require more energy, more silicon, and more cost than most of the world can support. This is where the future of AI reaches a breaking point. And it's where EvoChip.ai introduces a breakthrough the industry has never had before. The survival of AI depends on achieving more with fewer transistors. At EvoChip.ai, we developed a technology that cuts the number up to 1,000 times. Artificial intelligence is now everywhere. Every day, we ask computers to process more data, train and execute more models, and give faster answers. All that computing power comes from transistors. Transistors are the tiny electronic switches that make up every chip. There are billions of them. More transistors make chips more powerful, but they also create more heat, use more energy, and raise the cost of each chip. In 2020, NVIDIA's A100 chip had 54 billion transistors. By 2025, its successor has more than 200 billion. If that keeps going, by 2030, a single chip could cost over $100,000. It could use about 2,000 watts of power, the same as a home. At that point, only the biggest companies could afford them. Google, Microsoft, Amazon, Meta, everyone else will have to use cheaper previous generation hardware. That means most AI progress would be controlled by just a few. The problem is not the chip. The problem is how AI is based. AI today is based on neural networks. These systems do thousands to billions of mathematical operations to solve even the simplest problems. As they grow larger, they need exponentially more transistors, chips, and electricity. It gets more expensive and harder to sustain. At EvoChip.ai, based in California, we started from the ground up. We created a new patented software technology called AlticoreAI. It is not based on neural networks. In Alticore, computing power grows only in step with the size of the problem. That means it can achieve the same performance using exponentially fewer transistors. It maintains exceptional accuracy while operating on a fraction of the hardware. Rather than forcing data through countless layers of computation, we bypass most of the arithmetic, using logic gates in ways that align with their natural efficiencies to create trainable models that demand dramatically less computing power and time. We proved this on real hardware. We began with a small and affordable development board called the Digilent RDZ7. It's often used by engineers and students to test new designs. Inside, it has a Xilinx Zinc 7020 chip. This kind of chip is special because it lets part of its circuitry be reconfigured, almost like reshaping the hardware itself. That flexibility makes it ideal for testing new ideas on that small, low-cost board. Alticore reached 100 million inferences per second per core, powered by a simple 9-volt battery. That means, by using 3 cores, it can recognize patterns or make classifications 300 million times every second on low-cost hardware. Then we tested it on a more powerful but still affordable development board called the Xilinx ZCU104. Its CPU runs at 1200 MHz, while the FPGA logic that executes Alticore runs at 187 MHz. There, Alticore reached 3.1875 billion inferences per second. That means it can analyze and respond to data billions of times every second, while still using very little energy. This shows that AlticoreAI scales smoothly from low-cost to more advanced hardware. Alticore builds its intelligence directly from simple electronic building blocks called logic gates. Logic gates are the tiny on-off circuits that make all digital decisions. Instead of using layers of software to simulate intelligence, AlticoreAI connects these gates in a way that mirrors how the data itself behaves. AlticoreAI's design supports a broad spectrum of AI use cases, from compact chips, personal computers, to advanced chips used in data centers. High performance is no longer limited to expensive systems. AlticoreAI runs today on Windows and Linux and supports engineering tools like CUDA and VHDL. Alticore's MCU platform targets the 8-bit, 16-bit, and 32-bit or more microcontroller markets, where power consumption, memory, math constraints have historically limited the deployment of machine learning capabilities. By generating inference engines using orders of magnitude less mathematical operations than on neural network weights, Alticore MCU circumvents the computational bottlenecks that plague conventional approaches. Why does this matter? Because it lets AI move closer to where the real world happens, into sensors, machines, vehicles, tools, custom ASICs, GPUs, and data centers. It means energy use and hardware waste go down, even as capability goes up. And it means AI can grow in every direction, not just upward into more complex chips. Fewer transistors, more intelligence. That's AlticoreAI by EvoChip.